Can everyone hear me okay? Oh, that does work. Are we going to get started? I heard another talk start, so I don't want to be behind. All right. Welcome, everyone. I'm Adam McNeilly. I'm a senior Android engineer at OkCupid. And today we are going to demystify architecture patterns. Chet just said in his last talk he hates this question. What should I use? I'm going to answer that question. So I guess I'm the person to talk to. So a little bit of background, if you've been doing Android for a while, you've probably heard some of these buzzwords. MVC, MVP, MVVM, MVI. 2 weeks ago, I just learned people are now referring to something as MVU. Put question marks, I don't talk about it today. But these are all of our options for architecture patterns on Android. And especially as someone new coming into the field, this is a lot to take in. And there's a lot of questions we end up having, like, why are there so many of these? What's the difference between them anyways? Which one should I use? This one actually has a really simple answer from a good friend of mine who is here at the conference but not in the room. It depends. Sam Edwards, if you know him, has this running joke that like, it depends is the answer to every Android question you have. Because two tools solve different things. And you need to understand like the nuances between them to determine which one you should use. And that applies here too, but you can't really make a decision about which architecture pattern to use if you don't really understand the differences they serve anyways. So that's the sort of question I want to tackle today. But you might even be asking yourself, why do we need architecture patterns? And whenever you ask that question, we get met with more buzzwords. Things like maintainability and extensibility. And when you read these words, they sound good. Like you should write maintainable software. But what does maintainable software mean? Does it mean it's like, oh, easy to add new features, or easy to fix bugs, or easy to read? Like maintainability is a good thing, but it's a little hard to define. Or my favorite word is robust. I hear this word come up a lot. We should write robust code. I didn't know what this word means, and I Googled it. And the dictionary definition for robust is like strong and healthy. Like, what is healthy code? Code isn't even a living thing. And testable, another word that like sounds good when you read it, but it's kind of hard to define. Like, what are we really working towards? And of course, like I still use these words. I realize like I'm a hypocrite. 2 of these words are in the abstract for this talk. But I wanted to kind of break them down. Like it makes the concept sound way more complicated than it needs to be. I actually think this whole architecture discussion could start with one simple truth that we can all agree on. And it's going to seem really obvious once you hear it. But basically, you can't put everything in the activity. Like we all know this implicitly. No one does this, but it's not often said, like, that is one thing you can't do. Or as one of my friends so graciously pointed out in proofreading, can't put it in your fragment either. No one wants all of their code in one spot. And why not? Well, number one, it's not readable. You know, some apps have tens of thousands of lines of code. And if that's all in one file, and do you want me to change something? Like, I don't even know where to start. Command F is only going to do so much in tens of thousands of lines. It's difficult to add new code if you want to add some new feature or some new label. Like, again, you don't even know where to look to start adding that. For the same reasons, you can't change existing code. And another thing to think about is if you want to write JUnit tests, you can't use an activity or other Android framework classes. And there's like an exception to that rule if you've heard of a tool like Roboelectric, but let's say for the intents and purposes of this talk, I don't want to bring in some new tool. I want it to be testable outside the box. So we need to break up our code. We need to get things out of the activity. And that's what architecture patterns are trying to do. They are a way of saying, here's how I've decided to break out my code. So let's explore some options. We're kind of going to go through them individually, but first I want to start off just giving a nod to ModelView controller. Specifically because this is one of the earliest architecture patterns. It was introduced in the 1970s as a way to organize our code. And the way it did that was by breaking out our application into 3 parts. And that's where the name came from. We had a model component, a view component, and a controller. Each of these 3 components had their own responsibilities. The model, this is your data source. That's all it does. This can be a database, it could be a remote server, it could be some text file or in-memory list. But all the model cares about is getting the data. The model should not care about the view. It doesn't need to think about how that data is displayed. So it shouldn't do any sort of massaging like, how do I take like user's info and build a like name, age label? The model shouldn't have any of that logic in it. It should just be, here's how I get a user object from wherever I want to get a user from. Similarly, the view, this is our visual representation of information. It does not care where the data came from. So you need to have a view that knows how to display a user, but the view doesn't care whether that user came from a remote server or whether it came from a database or whatever else. It just needs to know how to display it. And I'm kind of hammering on this point. The view should only be responsible for displaying data. And so if your view has like some conditional logic in it, this is like an easy sign that you should consider refactoring. We can't always do this, but it's just something to think about. And so as the last component, the controller basically handles everything else. Takes in our user inputs. It validates those inputs if it needs to. And it passes those inputs to the model and passes that response back to the view. So the way to think about a flow like this is maybe a form. The form handles all the user inputs, verifies that you've filled in all the fields, sends that to the server, and then if it gets a response back from the server, shows the view, hey, like form submitted. So if we remember back to our first slide, and all of the patterns we looked at, the model and the view components are the same. MV star is what's consistent among all of these. And the responsibilities we just looked at are the same among all of them too. And so now it feels like this kind of joke, like this is a great tweet from Chet Haas as well, coming up with an improv game where you just describe the architecture for model view, random word from the audience. Because we have so many of these and it feels like that's what we're diving into, like what you can have model view, whatever the F you want. That's where the title of this talk came from. But we still haven't answered the question, why do we have so many options for this third component? What's the difference between them? Why do we keep adding new ones? And we're going to break them out individually, but I wanted to put a short answer in front of you to think about throughout the rest of the talk, which is state management. Each of the patterns we look at does something new for us for managing the state of our application that the last pattern doesn't do. And we'll see that in practice, but I just wanted to put it in everyone's head while we talk about it. But to get to the long answer, let's break them down. So here's a diagram of like what a model view controller flow would look like, and I'm going to see if this works. Cool. So we have a user. The user interacts with the controller, like we said earlier. And we have a view that displays information to the user. And then up here, the controller fetches data from the model. This sounds pretty good in practice. All of our concerns are separated. It's easy to see what the flow of data is. But as I mentioned, like, we don't really use model view controller in Android. I think of all the patterns that were on the first slide, this one comes up the least in Android. And there's a reason for that. If we think about the view's responsibility for displaying data and the controller's responsibility of handling user inputs, well, in Android, that's the exact same class. That's the activity or fragment. So the problem we run into is, well, we can't write JUnit tests for an activity, so all of that UI logic I talked about can't be tested. And we also don't really have a separation of concerns here. Sorry, 1 second. Because we have two components that we end up writing in one class. So enter model view presenter, which is basically the same thing, but we want to pull that presentation logic out of the activity class. So we still have three components, but now the flow is a little different, where the user interacts with the view, then sees the information from it, and the view has a reference to the presenter, passes that interaction through, and the presenter tells the view to update the UI. We have two-way communication here. This is important. We talk about that later as well. And still, the presenter only talks to the model. So why is something like this better? UI logic's outside the activity, now supports JUnit tests, and our concerns are separated again. So I want to go into, we talked about it as a concept, and I want to briefly talk about like the implementation of a tool like this. And here's where I'll go a little slower, because we're going to look at some code, and I don't want it to be too complicated, so we'll step through it, and hopefully it doesn't lose anybody. So when we're implementing something like MVP, the first step we usually do is create like a contract class. And inside there, we want to define the interfaces for each of our components. So here we have a view, and let's say we want to show like a list of tasks, like a to-do list app. This is what we would use. Our view needs to be able to show tasks. We have a presenter, which needs to be notified like when a view is created and a view is destroyed, and a model whose only responsibility is fetching those tasks. The implementation is relatively straightforward. So here I've created like an in-memory task service that just returns some sample apps. We notice it extends our task list contract.model interface. The view looks complicated because there's a lot of code, but basically we have an activity. Notice the view has a reference to the presenter. I should go back. The model doesn't really reference anything. The model just does what it needs to do. It actually has no knowledge of a presenter or a view. So in our view, though, we do have a reference to the presenter. So in this example, we have the view create the presenter, and we'll look at that constructor on the next slide. But you could also do this through like dependency injection if you want. That's a little more complicated. And then what we do inside the view is, in the relevant lifecycle methods, we call to our presenter to say, hey, view is created or view is destroyed. If you had some button that you wanted to handle a click listener for, you would do the same thing. You'd set the click listener inside your activity somewhere, and then you would tell the presenter that a certain button was clicked. And then the view knows how to show tasks by setting them to the adapter. And it's important to think about it this way because the view, it just cares about like displaying data and handling the user interactions. So the view tells the presenter that the view is created, which we can kind of imply that means we're going to fetch the tasks. But the view doesn't need to know that. The view is just responsible for saying, hey, this thing happened. And it's the presenter who makes the decision on loading the tasks when that happens. And that comes into the unit testing aspect we talked about earlier. Because I can unit test the presenter. I can't unit test the view. So then the implementation of this is relatively straightforward. Our presenter has a reference to the view, a reference to the model, and it extends the class from our contract. When the view is created, we want to fetch those tasks and show those tasks. And then when the view is destroyed, we null out that reference. This was important to add, not so much from an architecture point of view, but in MVP, where we have this two-way communication between the presenter and a view, and our view is often an activity or fragment that has a context, we want to make sure we don't have any memory leaks. So anything that's referencing it, like this presenter, we need to make sure to clear that out, which is a little different from the next pattern. So keep that in mind. All right, MVP was actually pretty easy to walk through and set up. So it's worth asking the question, like, is this enough? Because our view does nothing but display data, which is good. Data fetching, all handled by the model. Presentation of data is handled by the presenter, which means all of our concerns are separated. Everything is unit testable. So honestly, if you think this is good enough, use it. This kind of goes to what Chet said earlier. You should use what works for you. But people like opinions. I have opinions at the end, but we'll go through this slide. But obviously, we're not done. We have more letters to get through. So what's different about MVVM from something like ModelView Presenter? Well, some could argue that the presenter doesn't need to care about the view. What if the presenter could just do some stuff and then expose like its state or expose like a set of tasks that the view would, or whoever's subscribing to it, would know how to display. So that's really the trend of ModelView view model, is we basically break, oops, this is really hard to work with, but it's flashy. We break this chain between the presenter and the view, and we just have something where the view observes these changes, but there's no direct reference to it, which is nice because out of the box, we don't have to worry about that memory leak problem I just talked about. But there's another benefit I will get to towards the end. So let's talk about that implementation, what the problems would be of changing that from the last one. So our model doesn't really change much. We still have just an in-memory task service, but it's worth calling out because we no longer have a contract class, we should still put some sort of interface behind our model because our view model is going to reference it. Our view model doesn't need to know the details of fetching data. It just needs to know the expected responsibilities of it. So we should still use an interface there. And then in our view model, it looks almost identical to our presenter, but biggest thing to notice now, we have no reference to the view anymore, which is cool. Instead, we expose these tasks. I'm using live data here, but you could expose information using live data or RxJava or, God forbid, event bus. That's an option. And then when we initialize the view model, we want to fetch the tasks. And then we set that value from those tasks onto our live data. So it's the same, ultimately it's the same flow as the presenter. The only difference is we're not dealing with the view directly. And so the view implementation, you'll see this actually looks, while the lines are a little different, it's, again, the same flow. The biggest difference is that instead of having a show task method, we instead subscribe to the view model, where we say, all right, whenever these tasks are updated and I observe that change, I'm going to update the adapter. So it's pretty much the exact same thing. But we get one new benefit with this. I should have called out, well, you may have noticed that in my view model slide, I just had a view model class. I wasn't dealing with the architecture component view model. But that's where this comes into play. Is since our view model doesn't reference the Android view, we can leverage like Android's architecture components to outlast configuration changes. Using ModelView Presenter, that's not possible. Like when the activity is recreated, my presenter is still referencing the old activity. Handling rotation is really difficult. But if we didn't have a reference to the view and said we could have something that would outlast that activity recreation, handling state becomes a lot easier. So let's talk about like going back to MVP, how would we handle something like rotation there? Well, first thing we need to do is update our presenter to save and restore state and modify the view to call those appropriate save and restore methods. So pretty easy, add two methods to our presenter, get state and restore state. And then inside the view, we call those methods. Implementing the handling rotation is very straightforward. The complexity obviously depends on what your presenter is doing and how complicated get state is. But implementing the framework for handling rotation is pretty easy. But it gets even easier in MVVM. All you have to do is have the view model class extend the Android architecture component, update our activity to use view model providers, which is how Android gets that view model that already existed prior to the activity being recreated. And since it outlasts config changes, there's no need to worry about saving and restoring state. We just resubscribe to the live data. So it's one new line in our view model class, which is extending view model. And then here, this is exactly the same as what we saw last time we looked at the activity, but now we use view model providers instead of like creating the view model ourselves. But with something like this, if I have an activity that shows a list of tasks and I rotate my phone, the same tasks are there. And I didn't have to deal with on save instant state or on restore state, which is a huge benefit we get out of MVVM versus MVP. That's the biggest difference worth highlighting. Is that enough? I mean, our view does nothing but display data. Data fetching is all handled by the model. This goes into all the things we talked about earlier. We can now easily save and restore state. If this is good enough for you, use it. And this is ultimately what I use the most often. But again, we're not done. We have more acronyms out there. So where does MVVM fall short? This is a pretty tricky problem to answer. So let's start by considering a more complicated state than just displaying a list of tasks. So here, let's say I'm fetching the task from somewhere, and I have three options for my state. I could be in a loading state, could be loaded with a list of tasks, or I could have had some error that happened. So if I want to implement something like this, I will update my view model that when it initializes. I'm going to show the loading state. I'm going to try and fetch some tasks. And if any exception happens, I'm going to show an error. And these are what those methods would look like. When show loading is called, we set the state value to loading. When task, like at fetch task is called, we get those tasks, set the state value to loaded. And if we need to show an error, we give it some generic error. This all seems fine. This is all unit testable. It meets all of the requirements we've been talking about. But what are the risks of having these methods? At face value, it might seem like nothing. I mean, these all methods, they do one thing. They modify our state. They're easy to read, easy to test. But a risk you can consider is that any methods in the class can call them. Like, it's on me to make sure I call show loading when I intend to show loading. And hopefully I'm a good programmer and I have good code review and that's not a problem. But in principle, I don't have that guarantee. So I can't guarantee that these state changes are associated with a specific action or a specific intent. And we have multiple methods that are manipulating our state. And we need to make sure that those don't conflict with each other. What happens if I tried to call like show tasks before show loading? It's kind of the same problem. So how can we mitigate the risks of something like that? Well, the perfect solution would be to have one single source of truth for our state, one thing that's modifying our state. So if we could do this through like a single pipeline where every action causes a specific change in the state, that makes our state changes very predictable. And then that's highly testable. So I don't have to stop and wonder like, all right, well, I have this method that sets the state to loading, and I don't know where it's coming from. If I could have a single pipeline where I could see, given this input, I expect this output, that would be much more predictable. And that's where ModelView intent comes in. That's the problem ModelView intent wants to solve. And unlike the previous patterns we talked about, intent isn't used to refer to like a third component here, but rather to capture the idea that we have the intention of doing something that we want to capture in our state. So the first goal with this is we want to make our state changes predictable in a way that we don't have in the last pattern. And you may have heard this word before. This comes from a web tool called Redux, but we can achieve this action with something called a reducer. It just has a single method for reduce that takes in an action and takes in a state, which is actually like your current state. And then given that action and given your current state, a new state comes out. Single flow, this is the only thing that can modify the state. So now we have very clearly defined inputs and outputs. So I have a when statement here, and I know when I got a loading action, I'm going to return the loading state. When I got the tasks loaded action, I'm going to return the loaded state, and so on. And then if else, like if some action happened that I'm not handling, I don't want to change the state. Like we'll just return the same one that we already have. So this is good, clearly defined inputs and outputs. We also need to make sure we have a single source of truth here. And we can do that by creating something, a state container called a store. The store will contain our state and expose it for anyone to observe. It contains our reducer instance, and it dispatches those actions into the reducer to modify the state. So the implementation of something like that, here's all the code I should highlight. So our store takes in an initial state we want to have and a reducer instance that I define myself. I have a callback. We could do this through observables, callbacks, whatever, but here we have a callback to be notified whenever our state changes. We have a reference to the current state. Whenever that current state changes, I'm going to call the callback. But the biggest thing to notice is like current state is private here. This store is our single source of truth. The only thing that can modify this store is this one class. And actually inside of that, the only thing really changing it is our reducer. Our store will open up a dispatch method that takes in an action, and it passes that into the reducer with our current state. So this is how we get that lockdown state management that we can't easily get just putting everything in our view model. And here's a diagram of what that looks like. We have our view. This, again, it came from a web tool called Redux. So ignore where it says React components, but we have a view that sends off some actions. They go into the dispatcher, along with our current state, into this reducer, and we get a new state that comes out. Biggest thing here, unlike the other diagrams we looked at, is this is a unidirectional data flow. We don't have to worry about two-way communication. Think of it in any other scenario where there's two-way communication. If two people are talking at the same time, that's very difficult. But if we have a clear path of where data is going, we get that predictable state management. But the reason I really wanted to show this diagram too is for those of you who already have an app that's using MVP or using MVVM, and you think you can benefit from like this additional state management, this store and reducer thing doesn't really need to depend on you using a presenter or a view model. You can use this flow to your app however it's already architected, which is really nice. So think of this view as your presenter or your view model. It can be either one. So how do we hook this up? Well, first we create an instance of our store. Our initial state is loading, and then we have our task list reducer that you saw earlier. And now in fetch tasks, instead of manipulating the state in the view model, I just dispatch that this action happened. And I still have to make sure that I'm dispatching actions in the right order, but at least I know that that state management is locked down. All right, So is this enough? All of the same things that we've already looked at. State management is clear and predictable. That's a new thing. If you think this is good enough, I think you should use it. And that's kind of the last one we talk about. So it's worth begging the question, is that the best we can do? And our state management is pretty solid. I can't think of a way off the top of my head how we could manage that even better. But there are 22 letters that I didn't talk about, so someone is bound to give me a better way. So what should you take away from this? Let's recap each of these patterns. So ModelView Presenter, it gives us separated concerns for unit testing everything. It's good for quick prototyping because it doesn't require a ton of setup. If you are someone who likes writing or you're just building a quick sample, it's really good for that because of its readability. Config changes are handled, but does require a little more work. And state management is unpredictable, which depending on the, again, size and complexity of your app, that might be a deal breaker. ModelView ViewModel, all of the same things, even better for quick prototyping because you don't have to set up a contract class. Can also be good for readability. Put a note in here, because I'm a blogger, so I think about presenting to other bloggers. Just be conscious about how you expose data from a view model if you're doing that. And then can handle config changes even better, but still our state management is unpredictable in ModelView ViewModel, even though everything else up to that point is handled really well. And then ModelView Intent, because it can work with a presenter or view model, all the things I keep repeating, separated concerns, testability, come with it out of the box. It's not good for quick prototyping because there's just a lot of setup and creating the reducer and creating the store. This can be confusing if you're showing it to someone new because there's some unfamiliarity. I think there's a high learning curve in implementing that beyond an example like you saw where we just have loading, loaded, and error. As far as handling the config changes, it depends on whether you're using a presenter or a view model flow. But our state management is clear and predictable. So this is really, really good. But I said I would try to answer the questions, give that opinionated answer to all of this. What should I use? So here's my takeaway on this. While MVP can get you up and running quickly, due to the boilerplate of the contract class and the work for config changes, I don't really recommend it. If your app is already using it, don't take that as you should feel bad, because you have separated concerns, you have testability, it does work. But if I was writing something new, not something I would recommend. MVVM is what I do recommend the most. It allows for separation of concerns and unit testing support and these config changes without a major learning curve. It's basically the same thing as MVP, you just separate that view dependency. But it's worth saying that if your app handles really complex user flows or states, MVI can give you more support for that state management. So the example we saw was just to demonstrate the concepts of MVI. But if I was really just building a page that loaded and displayed some data, I wouldn't go through all that effort. But something I did do it recently is I have a rating mag in our app that asks you if you're enjoying the app. And depending on when you say yes or no, it sends you to another rating mag that has a positive and negative button. And that sort of complex decision tree is really hard to manage in one view model class. That's where having a reducer where it's clear inputs and outputs can help a lot. But the most important thing, I would say among all of that, depending on what you pick, is just be consistent. Have something that works for you and the rest of your team. And if you're working on one project, or a large project with a lot of pages, it helps if they're all the same thing. So I don't have to context switch and oh, this home page is built in MVP, but this new thing is using MVI, and I have to do a lot of context switching there. I think if you're consistent, and you have something that works on your team, that's what'll matter the most. So thank you, and here's a GitHub link with a link to the slides. There's also a sample app there for the task list that I showed. There's a module for each of the patterns we looked at. So if you want to dig more into the code for a specific pattern and try and add on to it, all of that is already there for you. So, thanks. I do have 3 minutes left. I think there are a couple microphones in the front. I am happy to take questions if anyone does have them. Oh, there's one there.
MVVI, I'm pretty familiar with the architecture with Redux based on Redux itself. And one of the key things with Redux is that you need to be very aware of using pure functions and that your data store is immutable. Can you speak to, in
Yes. I can speak specifically to the mutability point that you brought up. So let's go back and look at bulleted list. Why do I do this to myself? Oh, yes, I'm sorry. So the question was, Redux as a web tool is often based on, sorry, I'm trying to do two things. I want to get back to the reducer. It's based on the concept of like pure functions, which, correct me if I'm wrong, the way I would describe pure function is like, it does one, I don't know how I would describe a pure.
There are no side effects.
Right.
All it is compute an answer.
Yes.
It doesn't interact with the outside world in any way.
So to repeat that, a pure function is something that just does one thing, computes an answer. There are no side effects. It doesn't affect anything outside of that method. And then also, it's important in Redux for state to be immutable. And so how do we handle that in Kotlin? Well, as far as side effects, hopefully your reducer just, given this action, gives this state. If you actually want to do something in the middle, if you want to like log that a certain task happens, I would look into something called a middleware, which you can add in MVI that will like do the logging step and pass that action on to the next step. But as far as immutability, so in this example, I'm using sealed classes in Kotlin for returning a loading state. But if my state wasn't a sealed class, if I was using a data class for a state, which is also really good, in the return thing, I can say, state.copy, which is a way of taking an immutable data class, and Kotlin will give you a copy of that with the changes you've specified. I don't have it up. If anyone wants to follow up with me, I can show you using a data class for a reducer, but that's what I would use to get that immutability, is data class gives you that really fancy copy method. So I'd say, I'm going to return state.copy, and then inside of there I would say is loading equals true. That's the field that I'm going to change. So I hope that's helpful. Data classes.
I'm curious also if there would be any memory concerns related to that, or is it
It's not something I've really thought about, so I can't really speak to it too much. Were there other? Oh, yeah.
Hi, thank you for the presentation.
Thank you.
Is it a true statement that MVI enables for higher code coverage for unit tests? And if so, can you share your thoughts on why so?
So the question was, does MVI enable for higher code coverage on unit tests? I don't know a lot about how like code coverage as a percentage is like quantified. I've heard that term. It's not something that I use on a regular basis. So I don't know if you really get more coverage out of it because you're still able to test all of the same things. But I think maybe the reason people might say that is because I have very clear inputs and outputs here, a reducer may be easier to test than a view model that has all of these methods that manipulate state. And so because more things can manipulate them, I feel like there are more edge cases to test. But I'm kind of guessing that it would be related to that reducers give you clearly defined inputs and outputs. So it's easier to test for that than the unpredictable state you get out of the others. I hope that's right. That's my best guess. Yeah? Any others? All right. I am here for the whole conference if anyone does have questions, and then my Twitter handle was at the bottom of that, so feel free to reach out to me. I'm not going to step all the way through. Thank you.